Okay.
Hi, everyone. Welcome back. I'm so excited. This is the last morning session of our educational day of May 2020. And of course, we have a whole afternoon of talks to look forward to. But first, I'm really delighted that we have Dr. Gunnar Blohm here today to give this last talk of the morning session. So Dr. Blohm is an associate professor at Queen's University for computational neuroscience. He's also a principal investigator at the Computational Sensory-Motor Neuroscience Lab. He completed engineering and physics studies at the Max Planck Institute, and he did his PhD at the Université Catholique de Louvain, working on the use of extraretinal information to compensate for self-movement. His current research interests lie in the 3D properties of sensory motor control and their role in the interaction of different motor systems. And many of you may recognize him as one of the leading forces behind Neuromatch Academy and the broader Neuromatch efforts, where he's done really wonderful work to help promote computational neuroscience around the world. So we're so delighted to have him here today to give us a brief introduction to writing scientific papers. And with that, please take it away, Dr. Blohm.
Wow, thank you so much for that amazing introduction. It's like I feel like very flattered. I hope I'm not all red right now. So I'm really happy to be here, but I have to sort of like start by maybe disappointing you a little bit and put out a disclaimer. And I'm just a scientist. I write really badly, but maybe to mitigate that, I'm willing to learn. And the other thing I need to tell you is that I have done no research with respect to writing per se. So everything I will say today, someone else has said it before, and I'm just sort of like compiling this for you, and hopefully that'll be helpful to you. Okay, so with that being said, science is not finished until it is communicated, right? So this is a very important message that has that Mark Walport has put out. I mean, I would actually go even further than that. I would say, if you do not communicate your work, then you might as well just go on vacation, because if no one knows about your work, it's as if it hasn't been done. And if you communicate it badly, people might not notice it. People might not get the message, in which case it's also a bit of a waste of time. And so it is worth spending a little bit of effort to essentially get the scientific communication right. And the one big way that we communicate in science is, or the most important way, arguably, is through writing papers. This is our main communication avenue. And it also, because it's our main communication avenue, I guess, is among the main evaluation criteria, at least in academia, but also in some parts of industry. And so that really makes writing, and in particular, good writing, a must. And so hopefully I will be able to give you some pointers today that would help you write. And maybe I can say up front that while I'm a bad writer, these pointers that I will give you should make writing very formulaic, in the sense that you can be a good communicator even if you're a bad writer. Okay, so what are the characteristics of good scientific writing? Well, you want whatever you're writing to be understandable, of course, right? You want it to be straightforward, no like zigzagging. You want it to be unbiased, obviously. You want to have a nice structure that is a nice logic that is well structured. You want to be precise, because science is precise art. And of course, it has to be evidence-based, right? So with that, you know all that you need to know. Go and write. And if I were to tell you that, this might be your reaction. You might feel like sort of overwhelmed. Like, where do I start? It's all nice and good that you told me that these are the criteria of good writing, but how do I achieve that? So let's see how we can achieve that. And one way to think about writing and trying to figure out how we can achieve good writing is to think first about how we actually read paper. How do we take in written science? And so I don't know like how you typically do this, but from my experience and experience of many of my colleagues and graduate students, etc., the way you typically start is that you come across the title of a paper, right? Whether that's on a journal page, in your Google search, in a table of content email, whatever you have. And based on that title, you essentially decide whether that's interesting or not. So the most important thing about a paper is the title, right? Because that essentially immediately allows people to decide yes or no. Is that appealing or not? Does that speak to me or not? Will I read on? If you do find the title interesting, what's the next thing you do? Well, typically you look at the abstract, right? So the abstract of a paper is the next most important thing. You want to get the abstract right. And it is worth spending a lot of time on the abstract. And this is something that people often don't do. And I'll get back to that. Once you have read the abstract, right? Typically what people do is sort of like, if they're excited about the study and they want to know more about it, right? Is they flip the pages or scroll down if it's online content. And you scroll down to the figures or flip the pages to the figures. And essentially what you're trying to figure out in that case is like, what is the quality of the science? What have they done? What's the story here? What have they found? And you want all that information with the abstract in mind, based on the figures alone, without reading the text. And only if you're sort of really into it, will you start reading the rest of the paper, the actual text, and dig into the details, right? So I think it's really important to keep that in mind, because it gives you sort of like a priority list in terms of what you should be focusing on most in writing a paper. And I don't know how you have started writing papers, but when I was a grad student, I started writing methods and results section. And I spent a lot of time writing methods and results section and rewriting them and changing them, et cetera, et cetera. And at some point when, my supervisor and I were sort of happy with the methods and results, I would start writing the introduction and discussion sections, right? And then when they were all done, we'd go like, great, let's submit it. And then like, oh, crap, I forgot the abstract. Let's quickly write an abstract. And so like the last thing that I would do very, very shortly before submitting the paper, right? And what I will tell you is essentially that this is the wrong way to approach things. Title and abstract should always come first. And you will revise it and change it and everything, but it should always come first. This is where you need to spend energy on, much more than what people typically do. Okay, so there is a really nice publication that many of you might be familiar with called 10 Simple Rules for Structuring Papers, written by Brett Mensch and Konrad Körding. And I will cherry pick some of the 10 rules here to make my point in terms of how I think that papers can be written better. So the first principle of structuring papers well, and writing well, so the first rule here is to focus on one single central contribution, and that needs to be communicated in the title. Why? Because the title is your hook, as I just explained, to the rest of the paper. So make sure the title is right. And then the next one that's really important is to tell a complete story in the abstract, because reading the abstract will essentially be the decisive part whether someone wants to go and actually figure out all the results, etc. And I see in the chat, legends. Yes, I'll get to legends. Legends are important too, of course. They're part of the figure. Okay, so focus on a single message in the title and the paper, right? It's not just about the title. One message, one paper. Why? Well, because people will only really remember one take-home message from a paper. If you have multiple messages, people might try to remember all of them. They will get confused. They will get mixed up. And ultimately, they will not remember anything about the paper, right? And the other thing that people often do is they sort of like tag on messages somewhere, right? Something they find really important and they want to also say. But you should know that no one will find those. These are hidden messages that will just get lost, aside from the one, really motivated graduate student that will read every single day part of your paper. So whenever you write and you have these additional messages or parallel messages that you want to put in, you want to ask yourself, are those important enough to justify a separate publication? And if not, they should get kicked out. You want to focus on one important message. Okay, so like I presented this to my lab yesterday, and they were like, "You need examples here." Okay, like let me give you some examples, and this is from my own papers. So here's an early draft title of a paper. It was like a model of the decision mechanism triggering catch-up saccades during visual tracking. Very bad title because it doesn't really tell you anything about the finding, right? So the final title was Confidence in Predicted Position Error Explains Saccadic Decisions During Pursuit. Now, this is much more precise to start with because it gives you, visual tracking. What is that exactly? Smooth pursuit, we know what that is. But more importantly, it actually tells you not just that there was some form of a model here, but it actually tells you what the model did, right? So it's about confidence in a predicted position error. That's essentially the main novelty of that paper that has been modeled here. And I'm not saying that this is the perfect title, but I'm saying that this is a better title than the initial one we had. Here's another one. The future is attended during smooth pursuit. That was a terrible title. It sounds like nice, short, and catchy, but it's actually a terrible title because you have no idea what's going on. What's the future? What does that even mean? Is attended in which way, right? And so the final title was the default allocation of attention is broadly ahead of smooth pursuit. That gives you a much better idea of what was actually measured and what the main finding was. Okay, so I hope that gives you a little bit of an example here. So, how do you write well? And I said earlier that writing is hard. That I'm a bad writer, but you can essentially reverse engineer papers and come up with a formula that makes writing really easy. And so let's focus on the abstract first because the abstract is really important. I want to go through every single part of the abstract individually here. And the abstract, like the rest of the paper, should have a CCC structure. CCC stands for context, content, conclusion. And I'll get to the same structure for the rest of the paper in a bit. Now, so how do you start an abstract, right? The first sentence is the introduction of the broader field. Give me the context, right? What is this all about? What topic are you going to be talking about? And in the next sentence, you will want to narrow down, essentially, the context to the point where you can ask the specific question that you will answer in the paper. So this is typically called the gap statement, right? This is the gap in the literature that you, in this study, will fill. So that is the context. These are the first 2, maybe 3 sentences, not more. Then you have the actual content. And the content very often starts with, here we, right? And that essentially is the transition where you know, okay, now I'm going to learn about the methods, right? And you essentially describe the methods and approach that you use to fill the gap, and potentially you motivate why this is a good way to do so. And once you have done that very briefly, you provide essentially an executive summary of the main results, the most important results, right? The ones that allow you essentially afterwards to make the conclusion, to interpret the results with respect to the question asked. So this is down to the conclusion component. And some papers stop there, some abstracts stop there, but very often people add the sort of optional statement about the broader significance, the implication to the field, et cetera, et cetera. So this is really every single abstract should have that form. And if you stick to that, it's very easy to write. Okay, so then once we have title, abstract, hopefully we've hooked in the reader, and the reader wants to go on. They will look at the figures, right? And figures are super important. Why? Because we're visual animals, right? We really like pictures, and a picture is worth 1,000 words. So it's really worth actually spending energy perfecting your pictures and perfecting your story through the figures. So figures should tell the story. It should tell the story of your scientific progress, right? You should start with the methods, how you proceed, and essentially the succession of figures should lead to the main finding, the take-home message, clearly represented in a figure. Okay, and I'm not going to go through this slide in all detail here, but it's important to know that if you are telling a story through your figures, through the text, right, you essentially providing a connection that the reader can have with you, with your work. And whenever such a connection has been made, people remember your work better. We remember stories much better than an alliteration of individual facts. And this is important because it allows you essentially to engage the audience and therefore get the audience brain to essentially retain the information you want to bring across. That also means that you should have some idea about who the audience is, of course, right? You always write to a particular audience. And having the audience in mind, right? Do you write to a math audience, a computer science audience, a neuroscience audience? Having that in mind sets different expectations of what they want to see, how you need to talk to them. Okay? This is how you will change the way you describe your story, essentially to connect to the reader. Okay, so let me tell you about some pitfalls and frustrations that come directly from bad figures. So you make bad figures, or people make bad figures. I made bad figures. And you submit them to the journal, right? As a publication, of course. So multiple things can happen. One is because they're such low quality figures, the editor or reviewers essentially could question whether the rest of your science, right, the rest of the paper is also low quality. Did you actually manipulate those graphs in some improper way? Did you therefore also manipulate the rest of your scientific content in improper ways? That can happen, typically not necessarily the case, but I've had the case where as a reviewer, I've had that happen. It was kind of like, there's no way. If these figures are just wrong, they're sloppy, the rest of the research must be sloppy. That's sort of like the implicit bias you immediately get when you see that. Now, more frequently what happens though is that reviewers or readers in general simply don't understand the point of the figures and get very confused, right? And as soon as you have confusion, that pretty much automatically means rejection. Okay. And of course, if they don't get the paper, if they don't get the figures, then readers or reviewers will lose interest as well, which this is really not what you want, right? And so essentially, making bad figures is ultimately a huge waste of time for you, because you will get rejected over and over again. You will, have to resubmit. It's extra work. You might have to patch up some figures, etc., etc. So I really recommend that you do spend the time to make good figures. Think about the story and the different elements of the story and how to tell them. So there is actually another 10 simple rules for better figures paper. So this is, by the way, the 10 simple rules, for those of you who don't know, is a series, an amazing series of the PLOS Computational Biology journal. So I put the cartoon, the comics background here to indicate that figures are just like comics. They tell a story through graphics, right? You don't need words to understand what's happening. You just need the figures and a few words, right? So here would be the speech bubbles, and in scientific journals, the figures would have legends, right? That would be your speech bubbles to explain a little more. So in order to tell the full story through the figures, you need to, of course, first identify the message, right? Very important. Where do you want to get at the end? What's the final message? And then you need to essentially design your figures to build up logically towards that message, right? Maybe you want to present some raw data, right? Or model simulations before you sort of have like a summary figure that brings it all together and gives the final take-home message. You want to make sure that you use color effectively. That is often done very wrong. We have a very strong association with color. We immediately pick up on that association between the color and the meaning associated, right? If 2 lines, 2 different colors presenting 2 different things, we immediately remember that this color represents one thing and this other color represents another thing. Now, if you flip the page and there's another figure with the same colors used, you immediately think of those colors representing the exact same thing as in the previous figure. If you switch that up, you will be confusing the hell out of readers. So don't do that. Use colors smartly, use them effectively, and use them consistently. And finally, so again, I cherry-picked from the 10 rules here. Message trumps beauty. It's very important that the message is right in the figure. And if you have to put like a hand drawing in of something, that is absolutely fine. Although there's nowadays enough tools available that you shouldn't have to do that. Okay, and I said I would talk about figure legends very briefly. Figure legends are super important. There's a lot of advice on how to make figure legends right. And I should say that every important piece of information about what different colors mean in the figure, what different line styles mean, what the different figure panels mean or show, should be in the figure itself, not the legend. The legend is just accompanying, giving a little bit more detail about the interpretation, for example, what you should be seeing, maybe some statistics or something like that, right? It shouldn't contain details about symbols and stuff like that, because it's very hard to go like, okay, what's this red square here? And then you have to read through all the legend to find, oh, red square means this. Okay, and now what's the green square? And then you go again and you try to find the information. That's bad. There should be in the figure a depiction of what these things mean. And so this link here essentially provides a whole bunch of advice on how to design the figure legends well. I don't have time to get into it, so I'm just giving you the reference so you have it, but I will move on. Okay, so let's get back to the 10 simple rules for structuring paper. Rule number 2 is write for humans, okay? And write for humans who do not know your work. And so one of the important things here is, what that essentially means is avoid jargons. Speak or write simply, right? And I put a cartoon up here, and in a way it's a bit of a joke, but this is essentially how we do things in science, right? So the cartoon goes, that's an interesting question. Certainly, precise determination of current temporal state is of utmost practical importance. While it is not possible to provide definite answers within the present context, future work will, you mean you don't know the time? So this is exactly, and this is of course a bit of a caricature, but this is really how many people write. They write in a very scientific, correct way with many complicated words. But it ultimately makes it harder to understand, not just for the outsider who might want to read your paper, but also for the insider, because we have to sort of like think about, okay, every single word, these are complicated words. How do they fit together? What does it actually mean in the end, right? So whenever you can, use simple words, use simple ways of explaining. You'll have a much larger audience. And of course, that means that you have potentially much broader impact. Okay, so how can we achieve clarity aside from writing simply? How can we achieve clarity in a paper? And there's a few really important things that we can do that are very easy to do. And again, this comes from the 10 simple rules for structuring paper. It's rule number 3, and I'm coming back to this that I've talked to you about already for the abstract. Stick to the context, content, conclusion scheme throughout the paper, at all different scales. Start with the paper scale. The paper is organized as context, content, conclusion, right? The context is your introduction section. The content are methods and results. The conclusion is the discussion section. Now, if you zoom in, each section of the paper is also organized as context, content, conclusion. For example, if you look at the introduction section, well, the first paragraph provides the context, yeah, right? Well, you will essentially go, well, you know, it's really important to understand how the brain works, right? And then you sort of like zoom in to the point where here's the open question. That's the gap statement, right? That's the first paragraph. Then you have to provide some background, right? So people can understand your study. So you want to say something about what's known about how the brain works. So these are all the middle paragraphs in the introduction section. And then the last paragraph in the introduction section is sort of your conclusion, right? You go like, okay, knowing all this, here is what we do, So here we do this, and then you provide a brief outline of your findings, sort of like as a conclusion statement, right? So the introduction section is context, content, conclusion. Every single other section is also organized like this. Method section, first paragraph, brief overview of the global methods. That's your intro. Then you provide all the details. At the end, you sort of conclude by saying, this is essentially what it allows us to do. Results section, you start off again. Here's what we set out to do. Here's the logic that we will present, that we will go through in the results section, right? Then you provide all of that, and then you summarize it at the end. That's your conclusion. Discussion section, first paragraph. Here's the question we asked. Brief summary, that's the context. Now let's discuss all that, right? Let's essentially talk about all the specific things. Let's talk about the limitations, first of all, right? Let's talk about how our findings match with the rest of the literature. And then at the end, what do we conclude from all this? So you can see that at the meso level, so at the macro level, it's context, content, conclusion. At the meso level, it's context, content, conclusion. And even at the micro level, so for each paragraph, you have context, content, conclusion, right? The first sentence of each paragraph is the context. Here's what this paragraph will talk about. Then you develop your argument, that's the content. And the last sentence of each paragraph should be your takeaway message. Okay? Now, the cool thing about this, the cool thing about having such rigid structure is that it's very easy to outline a paper. It's very easy to organize a paper. You think about the story, well, what do you need to talk about? What are the different aspects you need to introduce? What are the different methods pieces you need to talk about? And you can outline them, and you know exactly that each item that you outlined will become one paragraph. So once you have done the outlining, which is a very important step in writing the text, you just fill each paragraph, and you can do that in random order. Okay, so I cherry-picked some of the 10 simple rules, but I want to briefly at least tell you all the rules because I think they're important. So rule 1 is focus on a central contribution, communicate in the title. Rule 2, write for human beings who do not know your work. Rule 3, stick to context, content, conclusion. 4, optimize logic flow, and that essentially just means that you avoid zigzagging and use parallelism instead. Now, in terms of the content, you want to tell a complete story in the abstract. You want to communicate why the paper matters in the introduction section. You want to make sure that the results are a logical sequence of statements and figures to support the central contribution. And then you want to discuss how the gap was filled, limitations of your study, and relevance. And in terms of the process, I said earlier, think about what's most important in the paper, right? Title, abstract, figures, and outlining in terms of content. This is where you should spend a lot more time than you typically would do on. The most important parts deserve a serious time commitment. And then finally, get feedback as early as possible at all stages in writing to reduce, reuse, and recycle the story. Okay, now there's a few extra things you can do that are more style-related, writing style-related, that can help improving clarity. And so I just briefly want to go through this. You can find the details on Conrad Körding's website. So one is in terms of sentences. You do not want to use parentheses that contain more than 6 words. Either what you put in parentheses is not important, and therefore you can just not mention it, or it's important enough that you should spell it out in a full sentence. Parentheses should be reserved for definitions, for example. Use active voice whenever possible. Many people write in passive voice. Active voice reads so much easier. Do not try to make language sound scientific. So this gets us back to the cartoon I showed earlier, right? Try to say things simply. It's much easier to understand. It's easier to read, even for specialists. And of course, avoid jargon, right? Use short sentences. No sentence should be longer than 3 lines, ideally 1 line per sentence. Again, it's much easier to read. And finally, one thing that people very often do wrong is they say something is really important, but they don't say why. So explain why something is important or interesting instead of saying that just saying that it is. So give me the why. And then there's certain words that we should not use. So for example, try not to use scientific words that use simple words instead. So circumscribe with like words that everyone can understand. Try to not use things like rather, very, little, pretty, these kind of like qualitative descriptors. Remember, science is precise. Do not use acronyms if you can avoid them. Nothing is worse than having to read a paper that's full of acronyms that you don't necessarily know, and then not being able to find the definition, and it's like a nightmare to read it. And of course, avoid jargon. I already said that. Okay, so with that in mind, how do you get to write? Well, one of the most important things to actually write and learn how to write is to get organized. And what I highly recommend for everyone to do is to create a writing schedule. And you might have heard that and sort of go like, oh, well, whatever. No, this really works. Block off time. Not much. You should be writing every day a little bit, maybe an hour, right? That's all. And you'll get lots done. Choose the best time of the day for you. When do you write best? Find your best writing space. Where is it that you write best? In what, do you want to have the coffee next to you, the cat on your lap? Is it on the couch or at your office desk, wherever it is? And then the other thing that people often don't do is that they don't make a plan. They don't define their goals for that day, right? So it's very important that you, for every day, every time you block off in terms of writing, you should essentially have a plan of what to work on. Today, I'm going to write the second paragraph of the introduction section. I have 1 hour for that. One paragraph, sounds about right. And you should also, and so the important thing is here, don't try to write all day. It doesn't work. Even very experienced writers, professional writers, typically stall at about 1,500 words, right? And depending on how long it takes you to write 1,500 words, that's sort of the absolute maximum time that you should ever spend writing in a single day. Otherwise, it just becomes inefficient, totally useless. So do it regularly, but do it in short, focused time spans, and you'll be actually quite productive. Okay, so many people have writer's block, and there's all kinds of people have different strategies on how to overcome that. One strategy is to just start writing, write down a first sentence, because we're often there like, okay, so how do I start this? Oh, no, maybe not. And so we just don't write anything. But a trick here is to just start writing. Write a first sentence that is, really, really bad, but like just, flow of consciousness kind of thing. And then just continue from there on. And it turns out that very often, if we then delete after the fact the first sentence, it's actually pretty good. And another method from that I copied from Randy McIntosh here is it's called the vomit method, which essentially means that whatever comes to mind that's related to the study, write it down. Just get it out. And then you'll organize where it belongs later. You'll delete it, change it, modify it, whatever it is. But just spit it out, right? That essentially helps overcoming writer's block. Okay, so finally, and I'm at the end here, we're all born scientists, right? As soon as we get born as kids, as babies, we love to explore, we love to learn. But we're not born writers. And in fact, we have to learn how to write. And in the same way, we have to learn how to write scientific papers. But the good news is that everyone can learn it. And with a sort of more formulaic approach to writing, everyone can write good scientific papers. Scientific papers with clear structure, the way I presented it. And in order to achieve that, there's nothing better then a lot of practice. Practice writing daily is the number one advice that I can give. And that's all I have. Thank you so much.
Great. Thank you so much for that really wonderful talk, and with lots of advice that I know I'm writing a paper right now, and there are lots of things that I can carry over into my own writing practice. So really lovely to hear your experience on this and advice. So there are lots and lots of questions. I figured we could take a few, if that's okay with you.
Yeah, absolutely.
So maybe to go a teeny bit out of order, one of the first questions I might want to ask is, you talked about the importance of abstracts and figures as kind of highlights of the paper to focus on, and bringing those two together. What do you think about graphical abstracts? Would you spend time creating a graphical abstract for your paper, either to present it to others or to organize it for yourself?
Yeah, absolutely. Actually, I had to do this the other day because Journal of Neurophysiology just mandated over the summer graphical abstracts. And we're like, great, paper's ready, all done. And then they get back like, whoa, you're missing a graphical abstract. And I was like, oh my God. And that was one of the first times I actually had to make one. And it was really informative and good to do. And it's not just, that it's sort of like fun to do the graphics kind of thing or whatever it is. It actually helps you really think about the core of the message and how to bring it across just through visuals in a very sort of intuitive way. And I think it's actually quite instructive and helpful to be able to do that for yourself as a researcher, but also to communicate your results. So this is the kind of, the graphical abstract is the kind of thing you want to put on a tweet, right? That's what everyone sees. And that's hopefully also a hook for people then to read the actual paper. So yeah, graphical abstracts are amazing. I can only recommend it.
I love it. Okay, I'll definitely have to try that myself. So another question, kind of going to this idea, you mentioned Journal of Neurophysiology mandated them. So if you're thinking, you've written a paper and you're thinking to take it to a journal, to a venue, do you have any advice on introducing a scientific paper in that context? Maybe writing a cover letter for a journal editor?
Sure. I mean, cover letters are mandatory. In cover letters, you want to provide some information that is not necessarily directly available from the abstract. So typically, as an editor, I would read the abstract. I would read the cover letter, and I would be looking for something in the cover letter that's not trivial, right? Why this is particularly important, why time is right, why we haven't been able to do this kind of stuff before right now. What is really cool about this? How does it benefit the wider research community? Whatever it is. You want to essentially use that opportunity to explain to the editor why they should be considering your paper. And I think the sort of like higher up the ladder you target in terms of journals, the more important it actually is to avoid desk rejections, essentially. I'm not sure I have a lot to say about those. Yeah, I don't know if there's any specific questions. I'd be happy to give it a shot, but I'm not sure what else I can say right now.
No, that's great. That's great advice. And the question comes from Francisco Cervantes. So if he can add in, that would be wonderful in the chat. That would be great. Okay, so there are a few more questions, kind of on the same line about thinking about publishing your work. Do you have any recommendations or thoughts about choosing a journal or conference? Particularly, I think this is a challenge for a lot of folks working here in NeuroAI, where we're so interdisciplinary. Do you have any advice for how you would choose a particular venue?
So talk to your advisor would be my number one advice. With experience, you get sort of like a feeling of, what audience can be found where, essentially, in terms of journals, in terms of conferences, the kind of feedback you want, right? So you might have some really cool results that combine neuro and AI, and you might want to take that to a neuro conference because you want feedback from the neuroscientists. knowing, is this anything reasonable here, or am I on the wrong path in terms of comparing my results to the brain or something like that. Or you might want to bring it to the AI field because you're really interested in getting feedback about the methods that you're using and stuff like that. So it depends on there's multiple factors that would influence in terms of conferences, at least, where you would like to take that. And again, like talking to other people, in particular your PI, your advisory committee potentially, is probably the best advice I can give you if you're sort of like uncertain about what to do. And something similar applies for journals. Depending on there is multidisciplinary journals, which is the good news for people that are sitting in between two chairs here a little bit. But again, researchers in the field, and starting with your PI, typically have a very good idea of where a particular story would fit best. And so I would, if you have no idea yourself, that's what I would do. There's no sort of formulaic way of answering that. There is recommender systems, though, actually on the internet, that where you can put your abstract in, and it recommends which journal it might be the most suitable to. So you can try that, with all the caveats of recommender systems.
I was going to say, I think that came up in the chat as well. If I'm remembering right, it's like Jane, maybe. I can't remember exactly the recommender system, but I'm sure we could find it. But yeah, no, that's great advice. I think that's really good to know. Maybe another question on, again, maybe sort of the difference between fields. So this is coming from Matma Ramazanin, and they're asking, this is probably field related, but use of personal pronouns such as we or our is sometimes not accepted within certain fields. And so is passive voice maybe acceptable or preferable in those situations where you feel like the field norms are against using personal pronouns?
Yeah, I mean, it's a good point that there is field specificity for many things. If you read like an engineering paper, for example, figure legends happen to be one-liners, which I don't even know why. It's like the most terrible thing in the world. But that seems to be the standard in the field in many cases. And so language, I don't know actually of any particular field differences in language, but I can imagine that also exists. So yeah, go with whatever is acceptable in a particular field, but whenever you can, try to use direct instead of indirect formulations.
It's really helpful. Okay, I think we have time for one more question. And it's kind of thinking about exactly what you just said about figure captions that are really quite short. Sometimes in certain journals, there'll be a preference for maybe really dense figure captions. Do you have any advice on how to kind of balance making sure the figure caption is descriptive enough, but it's not so dense that you're kind of obscuring your messages?
Okay, so first of all, one message is one figure, whether that's a single panel or multi-panel figure. If you cannot find a figure title that encompasses all the figure panels, you need to break up your figure, right? So that's first one. And the fact that you have only one single message that should be in the title essentially of the figure, right? Should make the figure legends much more compact, because you don't have to introduce 3 different things, right? Now, the length, again, there is some journals have different requirements. So some journals, for example, want all the statistics and the sample sizes and all these kind of things of whatever is presented in the figure panels to be directly in the figure legend. And of course, that blows the figure legend up quite a bit, right? Some do not require that. My recommendation, of course, is to always follow the particular, always read the author instructions for each journal. And I know it's a terrible system that shouldn't, these differences should not just not exist. But the fact is they do exist, and so we have to just deal with that. The good news, though, is that they're getting fewer and fewer. More and more journals are getting rid of them, or at least unifying them. The figure legend should provide clarity with respect to the meaning of the content of the figure. And it should be as brief as possible. And of course, that doesn't tell you much. And as long as necessary, as usual. And in a certain way, it's a judgment call, right? And more experienced researchers like UPI would probably be able to tell you, hey, look, you need more than one sentence here. Or would say, like, look, 3 pages figure legend is just not okay. That should go in the main text, right? So there's definitely a balance to be found here. I'm not sure there's a particular formula for this, but I think the link that I provided to how to make good figure legends provides some ideas on the kind of content there should be versus some of the content that should not be there. Hopefully that helps.
Perfect. No, that's great. Thank you so much. And so with that, I think we can wrap up the morning session for our main 2020 educational day. Thank you so much again, Dr. Blohm, for a fantastic kind of introduction to writing scientific papers. I know it's helped lots of us here. I just want to make a few quick announcements before we break for lunch. The first is that we still have our job board up. So if anyone wants to post jobs, or if you're looking to find a new job in the neuro AI sphere, that's a great place to go and check out. The second is that while you're stretching your legs in the physical world and getting some food, if you'd also like to say a quick hello in the virtual world, we'll have a Gather Town open as well. And just as a quick reminder, if you're comfortable, please include your personal pronouns in your Gather Town names so that we can all have really positive interactions in that space. But then the next thing after Gather Town and lunch will be even more exciting lectures this afternoon. And Dr. Piabelek will be chairing those. And we're so excited to continue what's been a really great day so far of Maine 2020 Educational. So with that, thank you all so much again for coming and attending and asking such wonderful questions. And we'll see you shortly.
Thank you so much. That was lots of fun.
Thank you.